Okay, next one is the slope of the line AC. So again, the points on point A, 1 and negative 3, and the coordinates of the point C, which is negative 1, 0. Okay, so the coordinates of C is our negative 1, 0, our x and y, while the coordinates for point A is the x sub 0 and the y sub 0, 1 and negative 3. So 0 minus negative 3 over negative 1 minus 1, that's negative 3 over 2. Again, you can interchange the coordinates of the points. Either you can assign the point A as your x and y, while the C as your x sub 0 and y sub 0. We could derive the same result. Okay, for the slope of line BC, okay, so for the x and y is the point C, and the x sub 0 and the y sub 0 is point B. So 0 minus negative 2 over negative 1 minus 3, that's negative 2/4, or that's negative 1/2. So that's the slope of a line. Now let's discuss the point slope form. The line passing through x sub 0, y sub 0 with the slope m has the equation y minus y sub 0 equals m times the quantity of x minus x sub 0. Okay, let's take for an example. What are the point slope form of the line AB using the point 1 and negative 3? I mean, the question is wrong. Using the point slope form, you should get the equation of the line. So I edited the question. Now the question, using the point slope form of the line AB, solve the equation of the line at the point A, 1 and negative 3. Okay, the slope of line AB was 1/2. We have previously get that. And here at the point A, 1 and negative 3, using this point slope form, we get or solve the equation of the line. So y minus y sub 0 is equal to m times the quantity of x minus x sub 0. So we have the coordinates of point A, which is 1 and negative 3. That's our x sub 0 and the y sub 0. And the m is 1/2. So the x sub 0 is 1 and the y sub 0 is negative 3, while the slope is 1/2. So y minus negative 3, that's positive 3, is equal to 1/2 times the quantity of x minus 1. So 1/2 times x, that's um, 1/2 x, 1/2 times negative 1, that's negative 1/2, and then transpose 3, then it becomes negative 3. So negative 1/2 minus 3 is negative 7 over 2. So the equation of our line is y minus 1/2 x minus 7 over 2. So having a knowledge on the point slope form of a line, we can get also the equation of the tangent line. So consider the graph of a function y is equal to f of x. Let point P is at x sub 0 and y sub 0 be a point on the graph of our function. So our objective here is to find the equation of a tangent line to the graph at the point P. Get the slope of this second line PQ. So in our prior knowledge, the slope of the second line or the line is y minus y sub 0 over x minus x sub 0. So that's the slope of the line from P to point Q. Since the tangent line is the limiting position of the second lines as the point Q approaches P, it also follows that the slope of a tangent line at the point P is the limit of the slopes of the second lines from PQ as x approaches 0. So in symbol, the slope of a tangent line is this one, limit of y minus y sub 0 over x minus x sub 0 as x approaches x sub 0. So we could have another one, which is, so from the xq it becomes, I mean the x and y here becomes x and the f of x. The reference for that is the point q, which is x and y is equal to the f of x. While the point P is x sub 0 and the y sub 0, then it becomes x sub 0 and then the y becomes the f of the x sub 0. So this is our reference to get the slope of a tangent line. So again, the slope of a tangent line is equal to the limit of f of x minus f of x sub 0 over x minus x sub 0 as x approaches x sub 0. While the equation of a tangent line is this one, y minus y sub 0 is equal to the slope of a tangent line, that's MTL, times the quantity of x minus x sub 0, where the x sub 0 and the y sub 0 is the coordinates of the point P. Okay, so to get the equation of a tangent line, there are two-step process we need to follow. The first one is to get the slope of a tangent line by computing the slope of a tangent line, that's limit of y minus y sub 0 over x minus x sub 0 as x approaches x sub 0, or our new reference, which is the limit of f of x minus f of x sub 0 over x minus x sub 0 as x approaches x sub 0. That's the first step. The second step is to substitute the value of the slope, or m, and the coordinates of the known point x sub 0 and y sub 0 and a point P on our point slope form to get the equation of the tangent line. So the point slope form is y minus y sub 0 is equal to m times the quantity of x minus x sub 0. For example, we find the equation of the tangent line to y is equal to x squared at x is equal to 2. So the x squared, y is equal to x squared, this is our y is equal to the f of x. So this is the f of x, or the function. Well, the x is equal to 2, that's our reference for the x sub 0. That's the point P on its x sub 0. So the x sub 0 here is 2. We don't know the value of y sub 0 yet, so let's get that, because that's very important to our to get the slope of a tangent line. So we have the formula, limit of f of x minus f of x sub 0 over x minus x sub 0 as x approaches x sub 0. We have the x sub 0, which is equal to 2. We have the f of x, which is x squared, but we don't have the f of x sub 0 yet. So let's get this one in order to solve the limit of the function. So the y sub 0 is equal to the f of x sub 0, which is equal to x squared, or 2 squared, because the f of x sub 0 is f of 2, so 2 squared is equal to 4. So the y sub 0 is equal to f of x sub 0, which is 4. Okay, let's solve our limit. So x squared, this is the function, minus the f of x sub 0, which is 4, all over x minus x sub 0, which is 2, as x approaches, again, x sub 0, 2. So the limit of x squared minus 4 over x minus 2, this is indeterminate form. If we substitute the value of 2 to our value of x, so let's get the real limit. So let's factor the numerator. So x minus 2 times x plus 2 over x minus 2 we could cancel x minus 2 in the numerator and denominator.